Hello, everybody, and welcome to the third lesson in this booklet called Proportional Reasoning 3. We already did 2 videos on it, so I'm scrolling forward, and you should have notes or watched these videos already, 1 and 2. And we're coming to page 15. Check it out on the bottom here. It's called Scale Drawings. We will make and interpret scale drawings. We will learn the meaning of scale factor and scale. So the first assignment is we have a face here of a Buddy, and this is our original drawing. Change all parts of Buddy's face given the following directions to create 3 more faces. They're probably Godfrey, Kilroy, and Dabney. Pay close attention to width and length. Let's look here. Here's your length. It's vertical. Each one square is 1 unit. So each one square is 1 unit in length. Width is horizontal. So that's also from here to here. Each little square is 1 unit. Okay, so this right here is your width. This is your length. Vertical length, horizontal width. Let's look at number 1. Godfrey's it's hard to say. Godfrey's face is twice as wide and just as long as Buddy's face. Draw Godfrey's face. So we'll go to Godfrey. So his face is twice as wide. So that's this one. We're going to multiply this by 2, but we're going to keep the length the same. It says just as long, right? So if we multiply, we have 4 units here. 1, 2, 3, 4. So those are my original 4 units. Now we're going to have to double that. That means we got to draw 8 units. So I'm going to start here, and I'm going to use my space wisely. I'm not going to start back here or right next to it. It's kind of a visual layout. I'm starting here, and I'm going 8 units. That's 3, 4, 5, 6, 7, 8. That takes me all the way to the end. This is how wide it is, but the same height. If you have a ruler, use one. And then we'll close it. Same height, but twice as wide. Now we have to decide where are those ear thingies. The height is the same, but the width is twice. So we're going to go from here to here. The height is the same. This is the height, but the width is 2 of these squares. Same on this side. So everything gets kind of elongated horizontally. Now let's see where the mouth is. We're keeping it at the same height, but we're making it twice as wide. It's 2 now. We're going to make it 4, and up it stays the same. And the eyes are going to be twice as wide. So 1 is here and 1 is here. I think that does it. Okay, the next one is Kilroy's face is twice as long, but just as wide. So we're changing the height, the length. So the width stays the same, but twice as long. That means it's going to go up 8. So I have to decide where am I starting. I'm going to start actually on the bottom here, and I'm going to go up 8. 2, 3, 4, 5, 6, 7, 8, and then still the same 4 over because we're not changing the width. We're making it longer. And then let's look at the ears. I'm not changing the width, so this stays the same, but they're going to be twice as high. So they're going to go like that. The width is still 1. See how it's still 1? We're not changing the width. And then let's look at the mouth. We're moving it up 2 because it's going to be longer, and we're making these little side thingies twice as long too. Everything is twice as long, but keep the same width. The eyes pop up 2, 1, 2, they come up here. There's Kilroy. The next one, Dabney's face is twice as long and twice as wide. So we're changing everything twice as wide. draw Dabney's face. So we're gonna go 8 by 8 for his face. So I'm gonna start here and go over 8 and up 8. 1, 2, 3, 4, 5, 6, 7, 8, and up 8. 1, because it's 4 in the original and up 4. See how they have the faces of 4 by 4 units? Each square is 1 unit. So now it's going to be an 8 by 8 because we're doubling the length and the width. Okay, so the ears also get doubled, so we're going to move them up and over. So this is now 2 and 2. Everything gets doubled. The mouth is going to get moved up and the side corners are doubled. And the eyes move up here and here. So there's Dabney. So look up scale factor in sections. You can look at it. I gave you a definition, discuss it. We won't discuss it now. Whose face represents Buddy's face scaled by a scale factor of 2? Scale factor of 2 is twice as big. Everything. So everything is twice as big. So that's Dabney. Whose face represents Dabney's face scaled by a scale factor of 1/2? That's half as big. Every measure is half as big. Not just the length, not just the width, but that would be Kilroy. So my scale factor 2 means twice as big. My scale factor 1/2 means it's half as big. This is called an enlargement. This is a reduction. If your number is bigger than 1, it's a enlargement. If your number is somewhere between 0 and 1, then it's called a reduction. Which of the two faces look most alike? That's Buddy, the first one, and the last one, Dabney. Okay, so that's called a scale drawing. Let's move on. This was page 15. This one is a birdhouse. So this is the birdhouse, but we're only looking at the front. We're not looking at the 3-dimensional part. So I'm going to draw the birdhouse here. This is going to be the scale drawing. So we're making a birdhouse, but we're drawing it small first. This is a birdhouse. So I'm going to go, first of all, each of these little things is 1/4 inch on my drawing, on my scale drawing. It's all in inches. So this is 1/4 inch, this is 1/4 inch, this. They're all 1/4 inches, yeah, on my scale drawing. I'm starting here and I'm drawing 3 of these. That makes it 3/4 inches. And I'm going up 3. That's again 3/4 inches on my scale drawing. This is not the real birdhouse. Then I build a roof and I'm going up 2 of these. That's called the height. So I'm drawing that with a little dotted line. This is 2 of these squares. That means it's 2/4 of an inch or a half. Yeah. And they're giving you the measurement of the side here, but that one you couldn't figure out until you know how to solve a right triangle, which we haven't studied yet. So I'm not going to give you the side length because you cannot measure it with a ruler. We're just going to use eventually math to find the third side. I know this is 2 squares means 2/4 inches. So I'm going to write that here. 2/4 inches is the same as 1/2. When you reduce it, okay? The diameter of the little hole that we cut this is called the diameter, where the bird flies in and out, is also 1/4 inch. Because it goes from one side of the square to the other side. That makes it 1/4 inch, right? Okay, now this right here, from here to here, because there's 3 of these, makes it 3/4 inches. And then of course, this is the same, 3/4 inches. So now I have all the dimensions for my scale drawing. Now I want to make it big, okay? So when we make it big, by the way, I have to also know that a 1/4 inch on my scale drawing is 3 inches in actual drawing. So each 1/4 inch is really 3 inches when I built my birdhouse, okay? So that part you have to know. You have to have some kind of start. You can't go blindly. They got to give you some clue. We're going to make a double number line. Remember, those are 2 lines that are horizontal. And use your whole paper. Usually we get a lot of numbers on here and they go on forever, but we're going and leave a little room here. Don't start at the front because we're going to have to decide what goes on there. And we'll label it. So I'm going to start here with 0, 0. No measurement, no real birdhouse. This line means the scale drawing in inches. We want to write our measurements. And this is the actual birdhouse. Also in inches. So our first clue is right here, 1/4 inch. So I'm going to draw a line and I'll say 1/4 inch on my scale drawing is 3 inches in actual size, correct? Yep, I made that up. I decided this is what's going to happen. So that's my first one. Now 2/4 in 2/4 is the same as 1/2 an inch. Is double as much, right? 2 is double as 1. So that makes it 6 inches in real life. 3/4 of an inch. I'm always going up by 1 inch, makes it, I'm adding 3 each time. It's a proportional thing. 3 plus 3 is 6 plus 3 is 9 inches in real life. After 3/4 comes 1 inch, 1/4, 2/4, 3/4, 1 inch. That makes it 12 inches in real life. This is an important one. That's our unit measurement, right? And we could go on and on, but I'm going to stop here. I'm going to stop here. So now I know that for each 1/4 inch, I have 3 actual inches, and I'm going to make my house this big. I want it to be 9 inches in real life. So I'm going to draw a picture here that could resemble the actual birdhouse. So I'm going to have it 9 inches by 9 inches. Okay, so 3/4 turns into 9. So 3/4 corresponds to 9 inches. This is how big I wanted. Now I have to decide how much am I going up? What's the height here? It's 2/4 or 1/2. So I know 2/4 or 1/2 is 6 inches. So I'm looking at my scale drawing and I'm going to go up from the middle. By the way, the height is in the middle here, up 6 inches. For the height of my roof. So all I have to do is look at my measurements down here. Then I know that the diameter of my hole I'm cutting is 1/4 inch on my scale drawing. So I go to 1/4 here. That makes it 3 inches on my real life model. So this would be, the diameter would be 3 inches. And it would also be 9 inches high. And I think that's all I would need to cut to make the correct. This is your scale drawing. This is your actual size. It's drawn to scale. I mean, I haven't drawn it to scale, but when you do it, actually, you have the correct measurements to make it look like that. So down here, we're going to write a few things. Let's see, what color do I like? Let's try this one. The scale drawing, so that's the smaller one, right? So we're going to write scale drawing. Ooh, what is this here? Don't like that. Think about it. Isn't it a reduction or an enlargement? It's a reduction. It's smaller, right? Reducing means making it smaller. Reduction of the actual drawing. The scale factor and this is your scale factor, is 1 to 12, 1/12. For each 1 inch on your scale drawing, it's 12 inches in real life. So this is your scale factor. Notice it's a number between 0 and 1. If you divide 1 divided by 12, you're going to get a decimal like 0.0833 repeated. That means it's a number between 0 and 1, and whenever your scale factor is that, it's a reduction. The actual drawing, did I record this? Let me see, make sure I'm recording. Yeah. The actual drawing, the big one, is called an enlargement because it's getting bigger, large, right? So those are the words you need to remember. Reduction and enlargement is an enlargement of the scale drawing, and the scale factor, because it's an enlargement, is the opposite. Scale factor is 12. Just the opposite. 1/12, it's 12/1 or 12. Notice the number is bigger than 1. So the bigger the number, the more you're getting it larger. Okay. We can also say the scale drawing to the actual drawing is 1 to 12. This is what you see a lot on maps and blueprints. Okay. So that's that page. Let's move on. This was page 14, no, 16. And now we're going to 17. All right. Yep. Okay, more birdhouses, it looks like. Natasha is making a scale drawing of birdhouses she wants to build, different ones. She completes scale drawing A, which is the first one here, on graph paper for the front face of the birdhouse. It's just the front face. It's not three-dimensional. Then she starts drawing B and C, complete drawings B, C, and D below. So we got to add a roof to this thing, and we got to add that little hole in the middle. Okay, everything has to be correct. Notice we're using 3 by 3. This is a 1, 2, 3, 4, 5, 6. It's a 6 by 1, 2, 3, 4, 5, 6. So it's twice as big. Okay, so it's twice as big. So I'm looking at my height here. It's 2, right? From here to here is 2. So I got to make it 4. Everything gets twice as big. So the height is always in the middle. Don't start it here. That'll give you a crooked roof, and then you draw your roof. So now the height is 4, and the thing here has a diameter of 1. We need to make it a diameter of 2. And we're done, correct? There's B. Now let's look at C. C is a little trickier. We have only this, which is usually 3. Now it's 2. Oh, and this is 1/2. Oops. Do you see how it's not going all the way up to 2? It's 1.5. So we have to decide how big is this. This is 3 to 2, so that's also 2 because it's a square. All 4 sides are equal. And that thing is about half as big. So it's a half a diameter. Okay, this teeny weeny thing here is just so small. Let's decide this is a 1, 1, yes? Let's look, let's fill in the chart. Drawing A, reduction or enlargement compared to drawing A, it's the same. So it's same, it's neither reduction or enlargement. It's the same thing, yeah? Drawing A compared to A, same thing. Scale factor, if it's the same thing, your scale factor is 1. It's called a multiplier, by the way, because you're multiplying by that number to get the new dimensions. Scale factor or multiplier are the same thing. The scale ratio is 1 to 1, same. Okay. Building B is twice as big. Do you see how 3 and 6 compare? 6 is twice as much as 3. Everything gets twice as big, so that's a enlargement. And the scale factor is 2 because it's twice as big. And that would make it 2 to 1. Twice as large. Okay. C is a reduction because it's smaller. And our scale factor is, I believe, 1/2. No. Nope, it's 3 to 2. 3 over 2 or 2. They're calling it 2 over 3. I would not. I would think A to C would be 3 over 2. Oh, but it's 2/3 as small. Yep, it's a reduction. The number has to be smaller than 1. Yes, 2 to 3. So it's 2/3 to 1. A little weird. I would have said it would be 2 to 3. And it's 2. C is 2/3 as large. So it's only 2/3 of the original one. And the last one is also a reduction, the little tiny one, and everything is shrunk by, let's look, it's a 1 to 3, right? So it's 1/3 as big. That's my scale factor, 1/3, and it's 1/3 to 1. And it's 1/3 as large. So that's how we fill this out. Okay, so you're talking about reduction or enlargement, which is pretty easy to see, but by looking at it, the scale factor or multiplier, if it's 1, it stays the same, 1 to 1. If it's twice as big, your scale factor is 2 because you're multiplying every part by 2. And here's your ratio. It's called a ratio. Okay. Reduction, scale factor is 2 over 3. Everything is reduced by 2/3. Okay, 2/3 is large, and this one 1/3 is large. Next page. This was page 17. We're moving on to page 18. You're lucky I'm not giving you anything you have to do yourself in this one. I'm doing it all because it's so much fun. Another way to describe scale factor is as a percent. For example, a scale factor of 2 could also be described as 200% larger. Okay, so it's just you adding 2 zeros and the percent sign. So we're looking at triangles. This is triangle A. Again, we're looking at height or length. This is usually called height in a triangle, which is vertical, and width, which is sometimes called base in a triangle because it's sitting on it, and that's horizontally. So length, long, base. Each one square is 1 unit. We don't know how much it measures. That's why you don't use a ruler. You just know it's 1 unit. Okay, let's fill in this chart. Triangle A scale factor is 100%. 100% as a scale factor as a number is number 1. And the ratio is 1 to 1. And it's neither an enlargement or a reduction. And the height was 4 units. And the base is 3 units. Count them. Yeah, 1, 2, 3, 4. Height, base is 1, 2, 3. So I filled that in, units. Okay, next one, we're going to draw this triangle B, 300% larger, meaning it's an enlargement. So the scale factor is 3. Just cross off these 2 zeros. That's how you do that. Okay, and it's 3 to 1. It's an enlargement. I'm shortening it. So if we have 3 times as big, we're going to multiply 4 times 3, which is 12. I'm just showing you the mathematics behind this. So it's 3 times as big, which is 12. 3 times as big as that is 9. You're multiplying it by 3. So let's draw it. 12 height, 9 the base. So because you're drawing several triangles here, I think there's 1, 2, 3, 4, 5, 6. There's going to be 6 triangles here. You want to make your space work for you. Spatial understanding on how much room you have. So we're doing 12. So I'm going to start over here, scooting it really close together. I'm going to start here and I'll go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 9 over. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 12 by 9 units, 3 times as big as this one. You only have to connect it. You don't have to worry about how long this thing is. So there's our triangle B, label it. Okay, this line looks really crooked. Use a ruler if you have one. So that's 3 times as big. Let's look at C. We only have one clue. Scale factor is 1/2. That's 50%. Okay, right here. It's 1/2. See, now here they do what I would do. Oh, that's weird. I would say it's 1 to 2. They didn't do that on the last one. And that's called an E reduction. Small, half is small, yeah. And so we're always going to start looking, start here. You never go back. Well, you could, but if you start here on the first triangle and look at these numbers, those are the ones I'm going to go by. If I want to make it half as big, it's got to be half of 4 and half of 3. So it's 2 and 1.5. So I'm going to come here. I have only 2 and 1.5. And that's called C, I believe. So that's a reduction by half. Then here, 25%, that's a reduction. That's 0.25, or it's 1/4. So it's 1 to 4. Now you can use your calculator. See how that works. It's a reduction because this number is less than 1. And so if it's 1/4 of 4, that's 1. 1/4 of 3 is 3/4. So you divide 4 divided by 4, 3 divided by 4. That's a tiny one. That's D. So that's 1 and 3/4. D. This one only gives us the scale factor that's twice as big, 200%, 2 to 1. It's an enlargement. Because the scale factor is bigger than 1. So if it's twice as big, 4 times, I'm always going back to my original. Notice, you can use these, but why? go back here. Twice as big means you're going to have 8 in length and 6 in width. So twice as big, 8 in length. So I'm going to plop it right here. 1, 2, 3, 4, 5, 6, 7, 8. And how much in? 6. 6 on the bottom. 1, 2, 3, 4, 5, 6. So remember, the first number is the length, which is sometimes called the height of the triangle vertically. The second number is the width, which is horizontally. So don't get those mixed up. Is it 8 and 6? Connect these. Ooh, that was pretty good. Yep, 8 and 6. Last one, 150% means your scale factor is 1.5. All you do is get rid of the 0, put your decimal right here. So that's actually they say it's 3 to 2, which is the same as 1.5. 3 divided by 2 is 1.5. It's an enlargement because our scale factor is bigger than 1. Multiply 4 times 1.5 and you get 6. Multiply 3 times 1.5, use your calculator, you get 4.5. So our last triangle F is 6 and 4.5. 6 high, vertically. Come on, stop. This thing is doing its own thing. 6 high, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 4.5. And then connect them. 6 and 4.5. And this is called F. And that one was E. Oh, stop it. That thing has a mind of its own. Okay. Hopefully you got that about enlargement, reduction, scale factor. Next, we're going to page, oh, there is one page that I want you to finish yourself. It's 21. Go to 21. I'll get you started. See if you can figure it out. I'll get you started up here. You will make scale drawings of sports playing surfaces. Well, that's usually like a rectangle. Yeah. Usually people play sports on a field like this, correct? Yeah. So draw a double number line that shows a scale of 1/2 inch is 10 feet. See, this is your starting point. You need that. So I'm going to get you started on your scale, on your double number line. That one we'll do together, okay? Whoa, nice and smooth. So here's 0, 0. No length, no width. The top is going to be our model or scale drawing. And we're going to make it in inch. What does it say? Oh, that's inches to feet. So the model is inches and the real life, I call it sometimes real life, is in feet. And we have the first one, 1/2 inch is 10 feet. So on our model, 1/2 inch is 10 feet. Now let's double that. 1 inch double would be how many? Think about it. We're doubling 20. I'm just using the number from here on out. How about 5 inches on your model? How much would that be? 1 goes into 5 times. That means this number has to be multiplied by 5 as well, proportional. How about 10 inches on our model? Double of 5, so it's going to be 200 feet. Remember, it's in feet. 15 inches on our model. I like the unit one, the one, because 15 times 20. 15 times 20 is, I believe, 300. Because it's 120, 15, 300, right? Let me try that. 15 times 20. Yep, 300. So I have it already up to, let's do one more, 20. 20 inches on your scale model would be 20 times 20 is, I know, 400 feet. These are all feet. Okay, so we have our ladder here, our double number line filled out. Now, your job is to figure out if a soccer field actual length is 400 feet. Actually, they do it the opposite. In these lessons, they actually do the length vertically. Anyways, that thing won't work then. Dang it. I have to erase. Just so that you say, oh, it's not right. Let's draw it like this. There's your soccer field. It says 400 feet in length and 300 feet in width. And you need to find the drawing length and the drawing width. So you got to look here. 300 feet in your drawing would be what? 15 inches. Oh, what about the width? 400 feet would be 20 inches. You can fill in the rest that way, hopefully. Now, some of these are not on your number line. Notice 60 feet is not here, but you can squeeze it in there. 20, 40, 60. That would make it 3 inches. All of these have a proportional relationship. You can find the number by squeezing it in and going 60 feet makes it 3 times 20. That means this number has to be 3 times 1. And you can find them that way. So there are your field, your soccer fields, blah, 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 and you find the drawing of your model. Good luck to you. Oh, and then we also have, like always, our vocabulary. So I'm going to make that homework, write it up there. And this is homework as well. So there's 2 pages. Good luck to you. Have a good one. Bye.